Derby students, Mr. Lawrence here, and today we're going to learn about the big F word. Yesterday we learned the little f word. Hopefully you got really good at that. Today we're learning the big F word, and that is factoring. Factoring is just breaking numbers, or in our case we'll be breaking polynomials, into their factors. For example, 12. Well, the factors of 12, especially if I do the prime factorization, pardon me, 3 times 4, and then 2 times 2. So the prime factorization of 12 is 2 times 2 times 3, right? That's what we're going to be doing. We're going to be breaking it down into its prime factor, so it can't be broken down anymore. Now, there's a couple different types of factoring we're going to learn. The first type is called factoring by the GCF. But before I teach you that, I want to practice the big D word one more time. I want you to distribute for me. Okay? Excuse me. So 2 times 3 is 6. X times x squared is x cubed. 2 times 5 is 10, and the x comes along for the ride, right? What we're going to be doing when we factor by the GCF, and by the way, this will be the first type of factoring you should always try. Did I say you should always try this type first? You should always try to factor by the GCF first. Hey, by the way, I don't know if I mentioned it. Factor by GCF first. Always. Not tomorrow, not the day before. Always. Always factor by the GCF. One more time, just in case Gotham isn't listening. Factor by the GCF first. Thank you. All right. So what we're going to do is we're going to come here and work at problem number 1. And we're going to determine the GCF of 10x and 5. What is the greatest common factor? Well, right now I can think of 10 as 5 times 2 times x, right? And I can think of 5 as, well, 5. It looks like their greatest common factor is 5. Well, I'm going to divide out that 5. I'm not going to throw it away. I'm actually going to divide by 5 here, divide by 5 here. But the 5 is going to end up outside of the quantity. I'm going to pull it out. It's like I'm undistributing. 10 divided by 5 is 2. There's an x there. 5 divided by 5, 1. I just factored by the GCF. I just undistributed the 5. I'm kind of thinking about this as, what number would have been distributed to get me this answer? Well, it would be a 5. And I'm always going to pull out the greatest common factor. All right, let me come over here, and now see, the better you know your multiplication facts, the easier the stuff's going to be. And so that's why I offered you quarterly challenges. Okay, I've got 12x and I've got 20. What is the greatest common factor? Well, I could say that 4 goes into both of them. 4 times 3x and 4 times 5. My GCF must be the 4. So I'm going to pull out the 4. So I'm going to have a 4 in front of my quantity. I'm going to divide by 4 here, divide by 4 there, and I'm going to get 3x minus 5. Oh, it's pretty easy stuff. Yeah, it is. Even with the more complicated ones, it's still pretty easy. Let's see here. GCF. Okay, for problem number 3. Well, 40x squared. Well, I know that of my x's. Well, here, let me express it this way. Hold on one second. Okay, so I could think about 40x as 5 times 8 times x times x. And I could think about 25x as 5 times 5 times x. Now, are you wondering why I used 5 times 8 instead of like 4 times 10? Because I knew 5 was going to be a common factor. I kind of cheated because I know my factors so well, because I know my multiplication tables. All right, so it looks like I'm going to have a 5 common to both, and I also have an x common to both. So what I'm doing is I'm dividing both terms by 5x, by the GCF. Now remember, when I do that, the GCF ends up out front. Okay, 40 divided by 5 is 8. X squared divided by x, x. 25 divided by 5 is 5. X divided by x, cancel. And there we go. Pretty simple stuff. All right. Now let's check out this number 4. It looks kind of big and strange. I've got 3 numbers to find the GCF for. 72x to the 4th, a 36x squared, and an 18x. Well, I think my GCF is actually 18. Yeah, I can think about this 18 times x. I can think of this one as 18 times 2 times x. And then I can think about this one as 18 times 4 times x times x times x times x. If I go and find the common factors, looks like I have an 18 in all 3 of them, right? I have 1x, and so I'm going to divide all three numbers by 18x. So of 18x, looks like I'll have 4x cubed minus 2x plus 1. All right, there we go. The whole trick will be finding common factors. Um, if you need to, say I wanted to find the GCF of these 2 numbers. Well, I'm going to break this down. 12 times 12. I'm not going to use 2 unless I have to. I'll worry about the x's in a minute. Okay, I'm starting to look for things that will prove to break down. 11 times 4, right? Now this isn't going to break down much more. I'm going to focus on this. I know that I can talk about this as 4 times 3, right? I'm not going to break down that other 12. Why not? Because I know that if you multiply this number times this number, you get 144. I also know that if you multiply these 2 numbers times this number, you also get 144. Well, what am I trying to tell you? I'm trying to show you that 4 times 36 is 144. How did I get it? 12 times 3. You see, you know that 4 times 3 times 12 is 144 because we broke it down in the factor tree up above. I can mix and match these in different ways. I can multiply these 2 first, get 36. Therefore, 4 times 36 is 144. Okay, this is a very important skill when trying to determine the greatest common factor. So now, as I look here, I see I have a 4, and over here, I have a 4 as well. Whoa, what was that? I thought I was in highlight mode and I wasn't. There we go. So part of my GCF is going to be a 4. Yeah, that's going to be the greatest number that goes into both 144 and 44 evenly. Okay? Now, how about those x's? Oh, wait, I should do GCF. I know my GCF is going to have a 4 in it. How about those x's? Well, here I have 5 x's being multiplied together. And here I have 3 x's being multiplied together. They're all factors. How many do they have in common? Well, let's see here. I have 1 here and 1 here. That's common. I have a second one here and a second one there. So now I'm up to 2 x's being multiplied, a third x, and a third x. So the GCF must be x cubed. Why x cubed? X times x times x. X cubed. Okay? If this were a problem like 144 x to the fifth plus 44 x to the third, and I was going to factor by GCF, I would divide both by 4x cubed. And of course the 4x cubed is out front. I would get 36 x squared. X to the fifth over x cubed is x squared plus 11. To check my answer, all I have to do is distribute. Multiply here, multiply here. If I get this problem, the black problem, I did it right. Well, 36 doubled is 72, doubled is 144. X cubed times x squared, x to the fifth, plus 4 times 11, 44, x cubed, and there you go, it matches perfectly. Okay, so that's how I think about it. Um, if you don't know your multiplication facts, this becomes much more difficult. You'll need to practice that. All right, Mr. Lawrence signing off. Have a good night, everybody.